Good morning, students. Mr. Carver here. Today we're going to be talking about the Trapezoid Rule project that we're going to be working on from now to the end of the school year. So let's first start out by talking about what the Trapezoid Rule is. Let me give you that formula. It's probably in your notes, but you may have forgotten it. All right, there it is. Just to call your attention to the coefficients of this portion right here. Remember, you have 1 on the outside terms and then 2 in front of every term in between them. B minus A is the distance along the x-axis, n is the number of subdivisions. So what you're going to be doing in the Trapezoid Rule project is you're going to pick a geographic area, whether it's a state, a lake, a country, something that's unlike Colorado and Wyoming, not rectangular or square in shape, something that's got like an odd random shape that couldn't be defined as by a set of like a common function. So something that's a little difficult to determine. And we're going to be applying the Trapezoid Rule in helping us find the actual, or rather just to get an approximation of the actual geographic area of that area, or that boundary. Or the state within. All right, so let me give you an example of what I'm talking about. All right, so let's say I pick Lake Ontario for the geographic region that I'd like to find the area of. What you're going to do is you're going to bring it up on Google Earth, and then what you're going to do is add these lines that I've got drawn in here. So you're going to be using the distance tool in Google Earth. We're going to start out by first determining the length of this area horizontally or latitudinally. And when you do B minus A, that'll be the distance. When you're calculating this, you want to make sure that all your units of measure are the same, so you're going to do it in either miles or kilometers. So your B minus A will be this distance from here to right there. And again, you'll be using your measurement tool to come up with that. And of course, 2 over n. N is the number of subdivisions. So that's the number of like trapezoidal rules, or not trapezoidal rules, but trapezoidal shapes that you're going to see in between them. Now, I didn't draw these super well here, but this line right there should really be starting right there. And then your final one over here, maybe move it over just a little bit farther. So in this case, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 subdivisions. So n in this case would be 11. All right, and then what you need to do is you've got to come up with these functional values in here. Again, using your measurement tool, you're going to be looking for the longitudinal lengths of each one of these. Now, if I put this boundary right at the edge of Lake Ontario on the left-hand and the right-hand side, I think you guys would agree that you're essentially going to get 0 kilometers or 0 miles at the very tip of the lake. Now, if you've got something that's got a square end, something that travels north and south, it may not be 0, but in this case it certainly looks like it's going to be 0. And then what you want to do is use your measurement tools to come up with these measurements in between. And I'm just estimating this. I have no idea what this is. Let's say this is 2.6. Let's say this is 3.7. So to start this process off, I've got 0 plus 2 times 2.6 plus 2 times 3.7. And you're going to continue across all the way until you've made it all the way across the lake here to the right-hand side subdivisions. Then you're going to calculate all of this out. And then what I'd like you to do is, that'll give you the number of square miles of surface area of Lake Ontario. Now, of course, this is going to be off slightly, right? This is nothing more than an estimate. But take a look at the rubric and make sure that you've got a sufficient number of subdivisions. I think it's 15 that I want you to have, at least 15. Something like that. Obviously, the more subdivisions you have, the closer you're going to get to the actual surface area of Lake Ontario. So I'd like you to come up with the estimate, and then I'd like you to actually do some research and find out what the experts say the surface area of Lake Ontario is, and then compare the two together, and then calculate, of course, the percent error. And I'd like you to put this on a piece of poster board, make it look nice, print all this out in color, and type it all up. Talk to me about why you think the error might be the way it is, whether you're under or over, and then that's going to be due on the last day of class. So I hope this is clear. If not, please email me, stop by and see me, and you'll be using class time to work on this. So you can either bring a device to class, or you can work in the library, And I think that's it. Take care of you guys. Best of luck.